Hey, welcome! Today we're gonna look at this Riden RD6030 power supply. Apparently it's able to spit out 1800 watts of power at up to 60 volts, 30 amps. And I have to say I've been using these RD series power supplies for like 2 years now, the 12 amp versions, and I'm quite satisfied actually. They do what they're supposed to, and they just work flawlessly. So let's take a look at the RD6030. This comes in 3 parts. The front panel, which you can get off AliExpress or Banggood for around $100. The case for about 30 to 40 bucks. And the internal power supply, which we have to talk about later. On the AliExpress listing it says that it's provided with a 1500 watt power supply, but it's 1800 watts, so quite a bit underrated. I found a 2000 watt power supply which I had to modify a little bit to fit in this case. This video is actually take 2. My first attempt was going quite well. I've showed the power supply and then I turned it back off and on and it blew my breaker, as it had quite a high inrush current and I lost all the footage. So this is take 2. So let's turn it on and see if it blows my fuse again. It doesn't, since I've included an inrush current limiter this time. I will show later which part, and you can get this part for around 30 bucks as well, and it protects your breaker from being tripped by turning on the power supply. The interface is quite intuitive. You set the voltage by clicking V and turning the knob, selecting the digit you want, or just enter the value you want and hit enter. Same goes for current, up to 30 amps. I'll usually leave it a little bit lower. I rarely need 30 amps, but it's good to have. You can switch between screens by hitting the arrow keys. A large, good visible display that shows information about charging a battery, for example. This module needs a power supply that can deliver up to 70 volts. Keep that in mind. This is not a power supply, it's a buck converter. Well, a power supply is a buck converter as well, which turns AC into DC, but we don't get into that. That's just a non-insulated power supply, which needs a power supply to feed it. It doesn't plug straight into mains. And I usually leave it on this display, it's quite good. You have a graph which shows current and voltage and wattage and temperature, I think. You can enter the menu by hitting Shift, Menu. Over there we have a few options like language and whatever take out and take OK is. I didn't mess with those settings. I don't need the boot logo, so let's just turn it off. You can set up the backlight, just increase it to the maximum. Well, my video lights are quite bright, so it's barely visible at 0, but I just leave it on 5. It's a cheap part. If it ever gonna break, buy a new one or replace it. You can set the max power of this power supply, the temperature unit, and the cutoff current, which is used for battery charging. You may notice there is a green terminal. This is not ground. This is a battery charging terminal. The power supply has an internal circuit to discharge the output capacitors once you turn it off. And when you hook up a battery to the positive terminal, it will try to discharge the battery as well and may even damage the circuit. So they included a third terminal, which you can hook up a battery. Once it senses a voltage, you hit enter, or OK on off. It clicks a relay and charges the battery until it's, well, drawing less than 100 milliamps or set by this value, and it shuts off the process. It also shows you how much went into the battery and everything. It also has a temperature sensor which you can put on the battery to stop it at cutoff temperature. I've just put the sensor on the internal power supply instead to see how hot it gets. I usually don't use this feature, and when I use it, my batteries, I always charge them at a really low currents, so they won't get hot. The next is the interface. It has a USB in the front, unfortunately in the front. I will prefer it in the back, which you can remote control it. It has an internal port to control it via RS422 or Wi-Fi if you plug in the module. And there is the options you can set. Interface TTL, I haven't found out what this actually is. Maybe it's the port itself. I haven't found any info on that. I haven't looked into the manual either, so maybe there is some infos on that. This is where you can set the date and time. I didn't have it set, and I didn't have a battery plugged in, which is necessary to save these settings. To exit this menu, just click the wheel once, and then you can click it again to exit the menu, or just hit the arrow keys to the left and right to select a different screen. On this screen we select the default home screen and the fonts. On this one you can select your presets or change it. This is just the info screen. My serial number is quite low, so this power supply isn't long on the market. Internal temperature, firmware version, everything. Unfortunately, the custom firmware from Unisoft is not yet available for this model. All of my other power supplies use this software. I can't tell for certain what's really better on it. It just feels better. I don't know. It looks the same, so you don't have to learn anything new. So let's exit the menu. Well, to turn on the power supply, you just hit on off. There we go. You see it ramps up the voltage and ramps it down. Actually, the ramp down is the discharging of the capacitor. The ramp up is in software. So I have just put my multimeter on the screen. It's a Keysight 304461A. Quite accurate. So let's see how the voltage on the no load are looking. I don't have any banana terminal plugs, so I have to just do this. And let's see, at 24 volts the view is a little bit lagging behind. My meter is much, well, that's bang on. What do you expect more from a $100 power supply? Let's go 5 volts. The multimeter is about 3 seconds slower on the screen than it is in real life. Yeah, about 2 millivolts out. 12 volts. What do you even want more? Let's go 50 volts. Yeah. Bang on. Maximum is 60 volts. There we go. Takes a while. 9 millivolts out. 8. This obviously changes on the load. So let's apply some load and see what it does. So I hooked it up to my electronic load via these leads, and I'm measuring directly at the binding post. Unfortunately, this power supply doesn't have any sense terminals, and these binding posts are pretty thin for 30 amps. Well, at least it has the same form factor as every RD power supply, so you can use it in your already cut hole on your workbench or whatever. So let's set the voltage to, let's say, 20 volts. I've set the constant current to 10 amps. Increase it to the maximum here. I set the load to 10 amps, I mean. Well, let's turn it on. It's at 20 volts. Let's enable the load. And there we go, 200 watts. The load can take 400 at both channels, so enable channel 2. There we go, 400 watts. No problem. The internal power supply makes quite a bit of noises. It's not the best quality. I don't know how long it will last. It's, well, you get what you pay for, right? Oh, that's 400 watts. Let's turn it back off. There we go. It handled that without a problem. And you may have seen on the measurement side, which I didn't look at actually. So at 10 amps we are out 14 millivolts, and at 20 amps we are out 30 millivolts. That's okay. That's really okay. Unfortunately, I don't have a load that can take the full 1800 watts. I don't have any nichrome wire and a bucket of water which I could dump some energy into. Yeah, it's not a full test. It's just a quick overview of this power supply. I don't think it can't handle this. My other power supplies, the RD6030 versions, they handle the 750 watts just fine. Well, it's a little bit less than this one, but I don't think this one couldn't handle it. RD is a really reputable Chinese brand, and their support is actually quite good. I blew the discharge circuit on my other one, on my 6012, and well, I asked them for schematics. Well, they won't give me any schematics, obviously, as they do nowadays, but they sent me a picture of the PCB and told me to check this and this part, if it's broken. They were broken, I replaced them, it's working again. That's really good support. Unfortunately, no schematics, as it is nowadays, but guidance to repair something is almost as good as schematics, isn't it? The next thing I want to try is measure ripple and noise. I don't think my scope is set up properly or my measurement method is right. I just do it like this and see what I get. Maybe someone who knows better how to do the measurements can do better than me. So I've hooked up my scope and I will enable it in the camera view. There we go. I've set up OBS so I can quickly display multimeters and scopes in my camera feed. I've set channel 1 to AC coupled with a 20 megahertz bandwidth limit. I'm using a 1 to 10 probe, and I've set it to 1 to 10. And here we go. Let's enable the 20 volts. Is it on, Jim? Yeah, no, the thing is moving. It's on. So let's zoom in a bit. Auto trigger. There we go. The noise is about 200 millivolts peak to peak, but it's pretty random noise actually. Let's see if I can trigger on some of this mess. Let's disable noise reject. And yeah, I cannot trigger on any of this. It's really random. Yeah, there's a little bit of switching going on. Let's see if I can see more when I color grade it. The majority is pretty low actually, so let's zoom in a little. Yeah, about 10 millivolts the majority, and all of the rest is really just noise. It may even come from the cheap power supply I'm using, not even sure, because the manufacturer rates this power supply at about 50 millivolts peak to peak ripple, and no idea what I'm doing wrong. I don't see any ripple, but maybe some of you who can read those signals better than me can tell me what's going on. So let's enable FFT and see what the switching frequencies are. I'm setting the horizontal to from 0 to, let's say, 1 megahertz. Not quite sure what I'm looking at. It looks pretty silent to me actually. I mean, I've seen worse. I've seen much worse on some DC to DC converters and other cheap power supplies. I think it's quite good. You keep in mind it's $100, right? Let's also repeat those measurements with a little bit of load. Let's say 10 amps and 20 amps. We are drawing 400 watts. So let's zoom in a little, about 400 millivolts peak-to-peak noise. And now I see some ripple, still quite random. Let's see if I can go any deeper than this. Color grade to see where the majority is. Well, I can't tell. It must be a really high switching frequency actually. So let's see what a FFT does. It didn't change. The noise floor went up, but no major peaks. So let's shut it down and tear it apart. The internal power supply has quite some big capacitors, so it takes a little while for it to shut down. You can see the voltage ramping down. So I've took it apart, and you can see the thermal video on the top left. So let's see which are the hottest parts. You can see this heatsink over there heated up a little bit. Not much, my hand is about 30 degrees, so it's not that hot actually. Let's take this off. We see there is a relay that got a little bit warm. That's okay. Nothing major. The transformer got a little bit of temperature. I think that's fine. Over here the power supply obviously got a little bit of switching losses. So let's see what's inside. This is the power supply I was talking about. Usually it comes in a metal case. I removed that because, well, it was too big. And you may see those fans that are wiggling around. It came with 2 fans and it needs those. So I mounted one on the back and one I'm pointing into the switching transistor part. And the fans have a extra supply, so it all is isolated. We have a full bridge over there, driven by some gate drive transformers. Big transformer here, and a diode bridge. And lots of bulk capacitors. These are 250 volts at 1000 microfarads. Probably 2 in series. So let's see what the other capacitor is. Apparently they are Nippon Chemicon. This one is 330 microfarads at 450 volts. And musical note. I don't know that brand. And it's probably the switching between 110 and 220 volt. That's what the relay maybe is for. We have 2 bridge rectifiers and input filter, which is rare to see on Chinese power supplies actually. The output capacitors are 1000 microfarads, 80 volt, from Chengzhou, Qingzhou, or whatever it's spelled. Well, you may see this wiggling about. I had to resolder it. Actually, it came with broken leads when the package arrived. So if you buy this power supply and take it apart, check those solder joints. And yeah. Let's talk about the elephant in the room. What's this? It's a Meanwell ICL16R. It's an inrush current limiter. It has a relay and some resistors inside, which slowly charges the capacitors, and once it sees a small enough voltage drop across, it switches a relay, and you won't get that high inrush current that trips your breaker. Over here we have the output going straight into the module at the front, and this is the temperature sensor I was talking about. I've just shoved it in a heatsink as I don't need it. There are 2 pots on the bottom. This power supply apparently can do even constant current, so you can use it on its own, and you can change the voltage from 0 to 72 volts. It only can handle 70 volts, so you have to dial it back a little bit, not much. I've set it to about 68. To get the module out, it's quite easy. You need something to push those tabs. I just use some brushes. There we go. And then over here. Let's see if I can find that tab. There it is. And there we go. So let's take a look at the RD6030. It's quite compact. It consists of 2 sandwiched PCBs. To take out the power PCB, you have to desolder the front terminals, unfortunately, so I won't do that. There you can see there is a battery, unpopulated battery holder for storing the settings. I'm not sure if all settings or just the time. The power supply apparently is based off a TL594C, so quite a common chip actually. And the heatsink seems to be glued down, so I won't take that one off. We have a little bit of input filtering, few capacitors on the input, few capacitors on the output, and a choke on the output. There is a auxiliary supply, probably for the front panel, and well, this NTC and this MOSFET over here are usually the parts that go when you feed back into when you feedback voltage into it for a long period of time, like when you connect 2 power supplies in parallel to get more current, like 60 amps, and well, you leave one on turned on. We have fuses on the in and output. Both are 40 amp SMD fuses. The power supply even comes with a spare one. The front USB is optically isolated, it seems. I didn't measure any continuity to the negative terminal, so that's good. And the modules you plug in here, especially the RS422, are also optically isolated, so you can hook multiple power supplies in parallel on one RS422 bus and control them all via one PC without them shorting out. That's the relay, a HF165FDG. It's a 5-volt relay. It can handle up to 40 amps, so good enough. Amazing how compact that is. 1800 watts. The 12 and 6 amp versions of this isn't any smaller. No idea. They probably found some really good MOSFETs they could use with a really low RDS on, and maybe change the circuitry a little bit with thicker copper layers, etc., to further reduce resistance and allow for 30 amps. I would like to see one with 120 volts maybe, or even higher. It doesn't need to be much amps. Like a supply that can do like 300 volts at 2 amps maybe, or 1 amp, just for fiddling about with tube amps, for example. There we go. To mount the power supply that isn't supposed to be in here, I've put it down where it roughly had some gaps on each side. I've marked the locations, drilled a hole, and used some metal standoffs. There's the grounding cable, and it goes through one of the standoffs into the case. So the case is actually low resistance to earth ground. Let's check that on my multimeter. Let's go from the ground to here, and 100 milliohms. Yeah, it's probably just the lead resistance, isn't it? Yeah, 50 milliohms. That's fine. That's plenty safe enough. If anything, any wire breaks or anything, my GFCI will trip. So, a little bit of glue putty here to keep the fan from wriggling. It presses against the case, and this one, well, I couldn't fit it anywhere, so I just leave it here, and this power supply doesn't get moved. It's not in a car or anything. It sits in my bench, and that's it. So let's put it back together. And obviously I'm missing one screw. Already actually thought of this, because in the back for this power supply there was a screw extra. So my breaker didn't blow this time, thanks to the inrush current limiter. And Well, it would have helped if I clicked recording, because I talked for the last half an hour. And yeah, take 3. So, there's a few tests I want to do still. Let's set it to about 20 volts with a limit of 15 amps. And hook up the constant current load. I'll just use some desolder wick for the positive terminal and clip my negative lead here. So, the test I want to do is short test. My constant current load has a mode which is called short. It shorts the output and draws, let's set it to 20 amps, because this is the channel maximum on my load. I've currently set it to a rising edge. I turn on the short. It's shorted at 20 amps, and let's turn it back off. And we see the voltage ramps up slowly again, and there is, well, almost no overshoot. Maybe even some undershoot, but that's nothing. That's really nothing. Now I change the trigger to a falling one, so we can see what happens when the short happens. Single trigger, and there we go. There is a little bit over here. Let's see how long it took. About a millisecond. Yeah, no undershoot. So the next test I want to do is setting my constant current load to a transient mode. Now I draw 10 amps and switch to 1 amp every half second. So let's see how it does that, how it behaves. It does that just fine. So let's go into the scope, AC couple, and scroll in. Let's see how it behaves. A little bit over and undershoot, about 50 millivolts between load changes. I call that okay. I've seen worse. Some other things to mention is you can change the graphing by rotating the knob. With the Unisoft firmware, if it ever comes out, you can change even more things like individual values. And you can also lock the instrument by hitting Shift Lock. To unlock it, well, you hit it again. This sometimes on some instruments happens when you control it remotely. I haven't tested it on this one. I have an instrument which does it, so it really depends. To use the presets, well, you set the voltage you want and the current limit, then you hit MEM and let's say M1, and don't click the knob, hit enter. There we go, we saved it. So let's go to, let's say 12 volts, 1 amp, and you want to recall M1, you hit Shift, M1, and enter, not clicking the knob. I always click the knob and thought why it doesn't work. So I just hit this and we have restored our preset. So, what do I think about this power supply? Well, I might be a little bit biased, since I have 2 already since 2 years, and I'm really satisfied with it. They have really good accuracy. There are, I mean, I've seen much worse power supplies in the past. The controls are really good. I mean, they're small for the power they can deliver. It's amazing. And with a ability to remote control it even. I would have liked if it had SCPI control and a USB port at the back, or at least RS232. But, well, wireless or RS422 will do the job. 1800 watts in this small form factor. Think about it. I have some other power supplies here. So if I tilt the camera down, these are quite some junkers. The upper one is a Delta Electronics 7045, so 70 volts, 45 amps at just above 3 kilowatts. The low one is a Gossen SSP 3052 at, well, up to 52 volts, up to 150 amps. Unfortunately, those need 3-phase power, even though in Europe we can supply on a 16 amp breaker more than 3 kilowatts of power on 220 volts. And these are huge. These are heavy and huge. And not that accurate, actually. And let's see over there. 2 HP, or let's say HP and Agilent, they're the same power supplies. This one, leave that out of the equation. It's just like 160 watts at 30 kilos. It's insane. It's not even that accurate. I mean, it has low ripple and noise, but This one is 1000 watts, also like 30 kilos, up to 50 amps though, 60 volts, and again some ranges to work with. You don't get the 60 volts and 50 amps at once. That, yeah, the math doesn't work out. But these are also quite huge. Let's take, for example, the Riden. I just unplug it and leave the caps discharging, so that's why it's still turned on. It's so huge. And it goes even further to the back. I mean, you can get 4 of these if your socket can handle it, can handle the power, if you need this much power. It's insane. And the best thing comes last, peeling the protective film. Nah, just kidding. I'll leave them usually on. I don't like peeling them off. It's an extra layer of protection. So what do you think about this power supply? I am really happy. Well, I don't think there is anything better at this price point actually. And the Riden support are quite good. As I said, with the discharge circuitry, they sent me a picture of the PCB watt to repair. And I mean, if they take the time to help me, that's just as valuable as sending the service manual to me. And RD Tech doesn't know I'm making this video. I didn't talk to them ever except for this problem I had a few years back. I got this power supply with my own money. I paid about 92 on Banggood for this one, about 35 on the case on Banggood, and the internal power supply was like 105, 110 maybe, plus 20-25 for the current limiter. If I had the need for more power, I will get a second one, or third one, or fourth one. I will fill my bench with these. But, well, use the 1800 watts first before you get the next one. I would like to see some models from Riden that span different range, like 120 volts, 300 volts, as I said, for tube amps maybe. And maybe one where you have symmetrical supplies plus minus 30 volts instead of 60 volts, so you can operate op-amp circuits. I have to use jumper wires to bridge 2 power supplies together to get a positive and negative voltage. It's a little bit annoying, but okay. If it's all in one supply, you even could track both channels, so you only have to set one and then follows the other one. Yeah. That's my video about the RD6030. Thanks for watching.